in your sights down, we completely understand. But we ask you to take a step outside to put the fire out so you don't accidentally burn down the speaker. So monitoring in production used to be collect all the logs. If something went wrong, the sysadmin searched the systems and logs for the reason and problem solved. Or, so we thought. RD came along, for those who remember, and metrics started becoming table stakes of the game. Then, just when we thought we had enough, tracing comes along and it's blown up everything else. So, we have techniques that help us understand what we've collected in KPIs and golden signals, read and used metrics. But all quickly becomes a situation that requires more than just a system administrator, even a team of sysadmins watching panes of glass and waiting for alerts. Monitoring itself has become a big data problem. And with that understanding, we can apply big data techniques to help us improve analysis and automate, or at least suggest solutions. So tonight, our speaker will show us how we might set up such systems against our systems, not just to knee-jerk automate, but to keep humans in the loop. So please help me welcome Sarah Spencer of Cognomind AI with her talk, Building Practical Automation for Real-Time Ops Intelligence.
Hello, everybody. Thank you for having me tonight. Sorry, I had this set up, but... What happened?
You touched it last.
No. Ron did. I had it set up, and then I don't know, he switched my stuff up. Swap, prevent, it's not even, is it plugged in?
There we go.
Okay.
Something must have gone on.
Okay, I'll stay away from the podium. I didn't touch anything this time. Is it on duplicate slideshow? Did it go up there? No. Okay. No. Okay. I need to see if I can pull my terminal up and my VS Code, so that's what I had set up before. Because I'm not going to PowerPoint you to death. We're going to do a demo. Promised a demo. We're going to do a demo. See? Okay. So maybe when I turn the presentation off, my terminals will show up. Okay. And then the flows, I just put in VS Code, so it's going to be that or GitHub. So anyway, like Mark said, my name is Sarah Spencer. I'm an ex-Cisconian, so thank you, Cisco, for providing this spot. I'm a fangirl, so I do love Cisco. Interestingly enough, I came back to the Bay Area from being in North Carolina with Cisco for the past, I wasn't with Cisco the entire time because I did go out and on my own venture and start Cognomind AI, which is a generative AI company. But I came back to the Bay Area. This is where I'm from. This is where my family is. And I said, let me go join some tech meetups and go hang out with some like-minded folks. And turns out that I used to work with Mark at my first IT job at Electronic Arts, well, EA.com. And he was one of the systems administrators that gave me my first shot and mentored me. So kind of full circle back to here. And who would have thought? Now I'm up here talking about deterministic automation and turning noise to action. And like Mark said, there's not a lack of telemetry or data. It's really the distance between the signal and the trustworthy action. And he kind of alluded to that. We have to audit and we have to verify it. And before you know it, we have petabytes of data, and it just becomes alert fatigue, logging into multiple systems. And so modern infrastructure doesn't have a data shortage. It has a decision latency problem, because we have to get the alert before it's too late to take action, and I'll talk a little bit about that. But we're going to demonstrate signals to normalize that telemetry coming in, then correlating it, enriching it, because we want it to be vendor neutral. So we have 34 vendors. One comes in as SVC for service. The other one comes in for service. We don't want to be customizing all of those alerts coming in. And then we want to be able to decide, and then we need safety gates, boundaries. We need to act. Then we need to verify that our automation did this correctly, because we can get a 200 okay, but what did that really tell us? Yes, but. So what happens when signals arrive faster than the decision pipeline can consume them? Something else we have to think about. And so at the end, we'll do some API calls with Python and Rust and kind of see the difference in the buffering and stuff. Signals are cheap, decisions are expensive, and actions where engineering gets interesting. So I will promise you I'm going to spend more time doing the demo than talking. But we need to ask ourselves, did the system needs to ask, did my action actually fix the problem? If yes, document it, close the loop. If no, we need to be able to roll back and escalate. So the first demo that we'll do is we'll do a degraded payment API, see how we can determine that. And the second demo is we'll do a failed rollback because there was a policy violation, like a database involved, and it will fail it. And then the third one, we will do the side-by-side Rust and Python call. So again, we've spent many years making infrastructure more observable, but more telemetry does not mean more operational intelligence. And so the problem I want to focus on today is not the collection of the telemetry, but it's the distance, again, between the signal and that trustworthy action. So this is the flow. We receive the signal. We're going to normalize the alerts and correlate them, enrich them, make a decision, put boundaries in place, act, verify that what we did actually worked, and then have an audit log of that. And I kept it simple on purpose because complexity belongs in policies and guardrails, not in scripts. And so when we're normalizing, I feel like I'm reading the speaker notes from the next slide. One of the biggest mistakes we make is treating every signal that it's something that requires an action. And that's how we end up with alert fatigue. Your automation systems need to start by accepting that most telemetry is just evidence and not a decision. So why don't we just get into the demo part. I'll pull that up. Nothing here is particularly difficult to understand. We see all of our payment APIs there. The alerts are pretty straightforward. And then we see that but it's the problem at scale, right? We talked about that, too much data, nobody's reading the terminal. And so the APIs become noise. This demo is going to simulate a production API that begins degrading, and instead of responding to individual alerts, a Python automation pipeline receives multiple signals, normalizes those signals, correlates them, enriches them, makes a bounded decision, executes a simulated reversible remediation, and verifies the result and creates an audit record. So we'll just run that right now. Presentation off. I don't know how to use PowerPoint, sorry.
I think there's a bit of latency also, there you go.
There you go. I did put the script in the slide. Might have helped if I got the script. I'm sorry, guys. I'm blind. Getting old, okay? I can't see. It's like I knew I put it on there.
Sarah, can you make your CLI font bigger?
Yeah.
We're also old.
But why isn't my
Not
script isn't working, first of all? Of course. No. I did it, so it's doing all the demos at once, but I did the present one so that I can hit next and like kind of talk through what the script is doing. So, sorry, kind of worked, but no. Looks like it worked. Is that better?
Command plus, try command plus.
Okay. Let me do that then and put it side by side by the thing.
Windows?
It is Windows. It's
Control
not,
plus, Control plus.
it's not, no.
The Windows plus?
Yeah, probably.
I think
Yeah.
Control Plus only works on the web browser, I don't think it works on the command window.
It exploded.
Control plus.
Wow, that's huge.
I can,
Now we can read it.
Except for it's like way over there.
Just made everybody in the back very happy.
Can you see it?
Yeah,
yeah.
for sure. Excellent.
Okay. But now it's all,
But you can't see it.
yeah, I can't see it. Okay, hold on. Let me,
Switch between Zoom and plus and minus.
crap.
Come in here,
Maybe if I do this and then increase it.
can you just set it to 150?
Yeah, I don't know why it keeps going to 200.
Yeah, we have to type it in there.
Okay, fine. Is that, go up, go up? See, now I lose my stupid, okay. Sorry, guys. I can't even see it now. There, finally. Type 150. Yeah? What about when I bring up the notes? It's not gonna let me. Okay, so the first thing that the Python script does is receive the raw signals. You can see that it's all around the payment API. We've got the alerts. And the Python is going to normalize the different sources into one event model. I really need my notes. That's not my notes. Okay, so you saw what it did. We'll go back. I'm terrible at presenting clearly. Huh? Alt tab? Mm-mm. I want to tell you what my script is doing, but I don't know. We're all... My view is like way off now. I can't even get it back. I don't know. I would do this in a meeting and engineers would be mad at me right now. Honestly. I'm sorry. Don't know how to work a computer. All right. Yes? So obviously the raw signals told us something's happening. It's all around our little APIs. I gotta fix this view. I can't go through this like this. So what we saw there was we had high latency, 500 errors, 503, some database connection pressure. Can somebody help me like fix the view of? Huh? I don't know. It's like all.
Looks like every time you get a long line, it's scrolling way over to the right because those are.
I know I need to get it back to its normal 100. I have 4 monitors set up, and sorry, I don't
So what do
use
you,
laptops very often.
what do you mean?
I just need it to go back to its normal magnification.
Okay. Is it on you?
I don't know. No, that's really small, but you guys in the back can't see it.
So I just looked up in the PowerShell, you control plus, control key plus, doesn't work.
I'm just going to use what I know, and that's my monitor. I'm going to do it how I know with my mouse. Okay. Okay, can you see that good? Okay, good. Sorry. I'm an engineer, not a speaker. I'm learning, I'm trying. I'm getting there. Okay, so. And the problem isn't these alerts. I mean, they're pretty clear. We know what they are. It's when we're getting them at scale that we're having issues with. So I'm talking through what that did. So we saw the latency before, after, the error rate, the replicas. And I don't even think I'm in the right spot because I was all, okay, the raw signals, yes, normalizing. So we want to make everything speak the same language again, because if we have different vendors coming in, they're saying latency with a different alert. They come in with different formats. One might say SVC, another service, another application, another APP, you get the point. And so conceptually, sorry, shit. Conceptually, it's going to look something like this, where we have the timestamp, the service, the signal type, the severity, the value, the source. So before I can reliably automate anything, I need the system speaking the same language. Otherwise, we're customizing this automation for 34 vendors. And then my decision logic shouldn't need to understand every monitoring vendor, every logging format. So I'm normalizing that complexity at the edge. And then we're going to correlate that data, and that's where it gets interesting. Your program counted the relevant events, and you should see something similar to payment API rolling window. We've seen that we had 4 latency violations, 3 HTTP 500 errors, and 3 database saturation warnings, and 1 CPU warning. Well, independently, are these events actually related? And here, they happen to be. But independently, the CPU may not mean anything. It's that we're correlating them. This was not a good idea for a presentation, obviously. They're happening together, and that's where we're able to match them to the known degradation pattern. So instead of alert, 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 I'm scared to go down. See? We now have a service degradation error. And we're no longer responding to alerts, we're responding to conditions. And that's the transition from noise to information. But before we touch production with this automation script, our automation knows that our payment API appears degraded, but that's not enough information to change production. So it looks up information about that service. And this is where we made sure to put information like, was the database changed recently? True. And it shows us the previous version, the current version. Oh, there was no database migration. Sorry, and the other one I did do a database migration. But we do know that there was a recent deployment 13 minutes ago, and that we went from a platform version 2.47 to 2.48. And that's huge because now we went from HTTP 503, which by itself may not mean anything, to we have a tier 1 production payment system with multiple correlated failures. There was a deployment 13 minutes ago. The previous version was healthy. There was a rollback available, and there was no database with the migration. Now in the demo that we're going to see that failed, it failed because there was a database on the migration and it couldn't roll it back with the database. So it failed it. So the telemetry said what's happening. Enrichment tells me what the event means in this environment. And so now the automation can decide what should we do. And the program evaluates a very simple rule. Conceptually, if service is degrading and there was a recent deployment and the previous version was healthy and confidence is high enough, then we can propose a rollback. And it produced, let's look at the script. That action. So, because I didn't show you the rest of this. So here it is where we normalize the telemetry coming in.
Can you explain what normalization means here?
Yes. So, and can you see that good? Yeah. An application might give you service equals payment dash API, and a different tool might give you service spelled out equals payment dash API, and the level equals error, and the metric equals latency on the next one. So you see they're giving you different metrics, and your database might give you another one. So they're different schemas, different terminologies, and different severity systems. So one system might be a tier 1 system, and one might be a tier 4 that we don't care about. But we want to know that because if we're thinking we're dealing with a lot of data, a lot of systems, WannaCry breaks out tomorrow, right? And we have 20,000 Windows servers. We can't patch 20,000 servers in 72 hours. So we need a way to be able to identify these systems based on their tiers. So when we do the normalization, we're asking, I want everything downstream operating against one predictable event contract. For example, what's the timestamp? What's the service? What's the signal type? What's the severity? What's the value? What's the source of the information? And so normalization isolates source-specific complexity at the edge. And if we replace the monitoring system tomorrow, we shouldn't have to rewrite the entire decision engine because we got a new tool. So normalization is just saying, if it looks like an apple and it tastes like an apple, we're going to make sure it's an apple. So we can handle I should be able to use this script whether I'm putting it in a lab to do normalization, or if I'm putting it in a production system using Splunk and something else, and then tomorrow go to another tool. My automation isn't tool or vendor specific. Does that make sense?
Yeah, so for each tool, you have an adapter so that your tool can see the same view.
So you're talking like using something like middleware like Taxi, so that when so like you're talking about, that's normalizing the data. So like if I have a database schema and model that I just put together, and I'm trying to, let's push information to ServiceNow, for example, or a monitoring tool, either way. And I use middleware like Taxi, that's kind of normalizing the data. But you can have the automation. This simple Python script is doing the normalization. So it's taking the telemetry in, and then it's normalizing it. Same as Taxi or some middleware. But you don't need middleware if you just do it at the edge, is I guess the point. Because if you measure twice and cut once, I think we forget that when we're dealing with data, the sanitizing and the normalization of the data should be the bulk of our work, because then the engineering part and the execution part doesn't take as long, in my opinion, my experience. But and so then the automation goes through, and it's going to enrich the data with that information that we just talked about. This is a tier 1 system, so we know that it is high criticality. It's in production, it's handling payments. We already talked about what happened there. And so now the automation needs to decide what the action is. And so somebody was talking about this earlier as, do we need AI? And in my opinion, we don't need AI at this part. And I actually wrote something up about that, because this is deterministic information that we're getting. It's not something that the AI is going to enrich. So, did you have a question? Oh. think it was this one.
Sarah?
Yes.
So, you say AI kind of like doesn't need to be here, but could it not be helpful for like some of that summarization or correlation stuff, or is that overkill in your mind?
Yeah, I put the point where I think that AI is useful, but I don't think at the correlation. Let me see. And it's probably on my PowerPoint slide. Because I wrote where AI is going to make a difference in this part. Crap, sorry. Like on the deciding what to do